Explain question 22, exercise 6.5, class 12. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of the two pieces so that the combination of area of the square and the circle is minimum? Means that the one length of wire is given, that make into two pieces and one edge is square and make and one edge is circle, and condition is given, the area of square and circle combined is minimum. So solution start. Let a piece of length L be cut for the wire to make a square. The other piece of wire to make into a circle of a length bracket of 28 minus of L meter. Side of square is equal to L by 4. Let R is the radius of the circle. Then 2 pi R is equal to 28 minus of L. So R is equal to 1 upon 2 pi bracket of 28 minus L. The combined area of the square and the circle A is given by A is equal to square area is side square. So bracket of side of the square of whole square plus 2 pi R square. So side of square is L by 4, so is equal to bracket of L by 4 whole square plus pi. Here put the R value, so 1 upon 2 pi bracket of 28 minus of L of whole square. So whole square is applied inside the bracket, so is equal to L square by 16 plus 1 upon 4 pi bracket of 28 minus of L whole square. Differentiate with respect to L, so dA upon dL is equal to 1 upon 16 is constant, L square difference is 12, so 12 upon 16 plus 1 upon 4 pi is constant. Differentiation of 28 minus of L whole square is 2 into 28 minus of L, and inside the bracket differentiation 28 is 0 and minus of L differentiation is minus 1, so it's equal to L by 4, L by 8 minus 1 upon 2 pi into 28 minus of L. Again differentiate with respect to L, so again differentiate with respect to L. d2a upon L square is equal to 1 upon 8 plus 1 upon 2 pi, because L 1 upon 8 is constant, L differentiation is 1 and minus of 1 upon 2 pi is constant, and differentiation of 28 minus of L, 28 is 0 and minus of L is differentiation is minus 1, so minus minus plus. If dA upon dL is equal to 0, then L upon 8 minus 1 upon 2 pi into 28 minus of L is equal to 0. So take the LCM is 8 pi, so L pi L minus of 4 bracket of 28 minus L upon 8 pi is equal to 0. So 8 pi is transferred to this side, bracket of pi plus 4, this 4 is minus 4 is multiplied inside, so here is plus of 4L, so L is take constant, so bracket of 4 pi plus 4 into L minus of 112 is equal to 0, so L is equal to 112 upon pi plus 4. At L is equal to 112 upon pi plus 4, then d2a upon dL square is equal to 1 upon 8 plus 1 upon 4 pi, that is constant also is find out, so is greater than 0. If by the second derivative test, the area is minimum at L is equal to 112 upon pi plus 4, because if second derivative value is greater than 0, that condition is minimum value condition. Hence the combined area is the minimum when length of a wire is making the square is 112 upon pi plus 4 meter, while the length of wire in making the circle is 28 minus of 112 upon pi plus 4 is equal to 28 pi upon pi plus 4 meter. That is the solution.